So we're going to wrap up chapter 1, talking about angle pair relationships. And so I'm going to have you thinking about a couple of things. First of all, what does pair suggest? How many are in a pair? That's right, two. In relationships, it probably ought to be between two people. Anymore, things get a little complicated. So when we talk about these relationships, the ones that we're going to talk about in this section, we want to think of them in terms of two angles. Okay, so the point here is to be able to identify these angle relationships and then use those to help find different angle measures. Now, some of these you've heard of before. So quickly, definitions: complementary, supplementary, and adjacent angles. You can stop the video and write these definitions real quick if you'd like. I'll give you a couple seconds to do that. Okay, but I'm going to keep moving now. So complementary angles are two angles whose sum is 90 degrees. Supplementary angles are two angles whose sum is 180. Now, complementary, supplementary, 90, 180. How can you remember which one's which, right? Complementary is 90 or 180. Supplementary is 90 or 180. Sometimes it's tough for students to remember. What I always do is, since complementary comes first alphabetically, right? C comes before S alphabetically. 90 comes first numerically. So since before 180. So since complementary comes first, 90 comes first, complementary and 90 match up, supplementary and 180 match up. Okay, might be a way for you to be able to remember that. Okay, now next, the idea of adjacent angles. Now this says two angles who share a common vertex and the side. Basically what I want you to look for, I want you to look for two angles that are side by side, touching. Right? So if this is angle DEA, then an adjacent angle to angle DEA might be DEB. Okay? Because they're sharing this side right here. So they got to be side by side and touching. However you want to look at it. Since it's an angle pair relationship, adjacent angles would be side by side and holding hands, or they'd be side by side and their shoulders touching. I don't know. However, well, whatever it takes for you to remember, but they're side by side and touching, not overlapping. Okay, not overlapping, side by side and touching. Okay. Now, complementary and supplementary angles can be adjacent, or they may not be. They don't have to be. Any two known angles in the universe can be complementary angles. There could be an angle in St. Louis and an angle in Chicago. And as long as their measures add to 90, then they're going to be complementary. They don't have to be adjacent. Now, they can be. And if they are adjacent, as in the case of these guys right here, then we actually get a free piece of information out of it. If we have two adjacent angles who are complementary, they're forming, so they're together forming this angle, which we now know must be a right angle. Since those two are adding up to 90, then the big angle must be a right angle. Okay? Same deal with supplementary. Don't have to be adjacent. One could be in LA and the other one can be in Albuquerque. And as long as those two angles add to 180 degrees, they're going to be called supplementary. But they might be adjacent, like these guys right here. And if they are adjacent, then again, we get a free piece of information from knowing that. And that is, if we've got two adjacent angles that are supplementary, then they're forming a straight line, right? A straight line, a straight angle, same thing. Okay? And we're going to use that idea. We're going to use both ideas a little bit later in the class. We're going to use the idea of this straight angle, straight line for supplementary angles in just a few minutes. Okay? But I wanted to make sure that I pointed that out. Okay. So first example here. Name a pair of complementary angles. Name a pair of supplementary angles. And name a pair of adjacent angles. Okay, so can you do that? Take a look. Can you find the complementary angles? Hopefully you are recognizing that angle BAC and angle RST are complementary. BAC is here, RST is over here, and if you add them up, you do get 180, or sorry, you do get 90, sorry. So those are going to be complementary. Supplementary, angle B, nope, sorry, angle DAC and angle RST. Because again, if you add 58 to 122, you get 180. And that's supplementary. Okay, adjacent. I'm looking for two angles that are side by side and touching, not overlapping. Those two angles are angle BAC and angle DAC. Those are your adjacent angles in this diagram. Okay, you need to be able to pick those out. Now, a couple of quicker, easier examples. Here we know that we're told that angle 1 is a complement of angle 2. And it doesn't mean they go well together, right? Like accessorizing your wardrobe. What this means is that angle 1 and angle 2 form a right angle, or they add to 90. And the idea of them adding to 90, if you're trying to solve some problems using the fact that 1 and 2 are complementary, it might be helpful to write these two guys out, write an equation out. So the measure of angle 1 plus the measure of angle 2 must equal 90. And then we can plug in what we know. Angle 1 is 68. And then to solve for angle 2, we just subtract from 68. Now you may be able to get there faster than setting up an equation and solving it, but just in case you're confused and it's not clicking with you yet, try to writing an equation, and that might help. Okay. Same thing if 3 and 4 were supplements. Okay. Then I know the measure of angle 3 plus the measure of angle 4 is going to be equal to 180 degrees. Now, if the measure of angle 4 is 56, then subtract 56 from both sides, and the measure of angle 3 is going to be 124 degrees. Okay? Again, you may not have to write the equation. You could maybe just subtract 56 from 180. You may get there faster than the equation, but I think the equation can help if you're if it hasn't quite clicked for you yet. All right? All right. A quick sort of real-life example here. Any of you soccer players or even basketball players, there's what's called a ball return net. If you kick the ball or throw the ball into that net, it'll bounce back to you or bounce to where you want it to go. But here we use the idea that this ball return net forms, right, a pair of adjacent angles with the ground. So if we consider the ground here, the ball return net here, right, then it creates two angles that are adjacent, right? They're side by side and they're touching. They're adjacent angles. And those two angles form a what? Yeah, they form a straight line or a straight angle, which means that they must add to 180. And if they add to 180, then they must be supplementary. So that's what we're told here. They form a pair of supplementary angles, angle BCE and angle ECD. Now we want to find the measure of those angles. Well, I just said, since they're adjacent and they form a straight angle, then they must be supplementary or they must add to 180. So we just add those two angles up and set them equal to 180. Subtract 10, divide by 5. And now we're ready to substitute angle 34 in for x right here and 34 in for x right here. 34 plus 2 is 36 degrees. 4 times 34 is, 136 plus 8, which is 144. And now, since one angle is 144 degrees, the other one is 36 degrees, if you add those two up, you do get 180 degrees, and so we must be right here. Okay? We can write that out in terms of the measure of angle BCE is 144 degrees, and the measure of angle DCE is 36 degrees. Okay? There you go. All right. A couple other relationships. And if you look at the definition of these guys, they can be pretty the definitions can be pretty confusing. So I'd like to give you guys an opportunity to come up with your own definition. And I'll let you think about it for a second. And then I'll write down what I think is going to be a pretty simplified definition. And you can use whatever you want to help you remember. Okay? So look at these two diagrams, here and here. Okay? The first set, angle 1 and angle 2, are a linear pair. Angle 3 and angle 4 are a linear pair. So, question is, what makes a linear pair? So stop the video, think about it for a second, start it back up, and I'll give you what I think might be a simplified definition. Okay, so hopefully you're looking at this and you're thinking, well, a linear pair, the difference between this and this is that angle 1 and angle 2 are adjacent. So it must take two adjacent angles. So two angles that are side by side and touching. But that's not enough. What else are those two angles doing? Well, they're forming a straight line. And that's why we call them linear. So the two adjacent angles that form a straight angle or a straight line. I'm going to write down line because the word linear, the word line is in linear. Okay? Now, if they form a straight line or a straight angle, I said it's the same thing, right? Then that means that they must be, or they must add to 180. And if they add to 180, then that means that they're going to be supplementary. So we can actually add this in. So when you're dealing with a linear pair, you need to remember that the linear pair is supplementary. Okay? Now, a little tougher to come up with your own definition is vertical pair, vertical angles. So I'll tell you in this first picture that angle 5 and angle 8 are your vertical pair, where angle 7 and angle 6 are your vertical pair. Okay? 5 and 6 aren't, because if you look, 5 and 6 are adjacent and they form a straight angle, straight line. So they're actually a linear pair. So are 5 and 7. So are 6 and 8. So are 7 and 8. Those are all linear pair. So what's the difference between 5 and 8 being vertical, 7 and 6 being vertical, but 9 and 10 are not? What's the difference? I had someone suggest earlier that 5 and 8 are opposite. They're back-to-back. They're opposite or back-to-back angles. And I like that. So they're not adjacent. These guys are not adjacent. They're two back-to-back angles. But you got to be careful because 9 and 10 kind of appear to be back-to-back. So we must add something else to it. So what else is in this picture with 5, 6, 7, and 8? Well, if you see, then the same class suggested that they're opposite rays. Their sides are forming opposite rays. The two back-to-back angles whose sides are opposite rays. And that makes it different than 9 and 10. Okay? Now, I'm going to add one more thing in here, and that is when you're looking for vertical pairs, or if you're checking to see if you have vertical pairs, then start trying to trace x's. If you can trace x's, then you're going to find vertical pairs. So the vertical pairs are angles that are in the x's that are back to back. Okay? And we'll talk about different letter tracing that gives you different angle relationships, but this is the first one. We're looking for nice straight-lined x's. Okay? 9 and 10, they don't do that. If you try to trace the sides, that's not any x that I've ever made. Right? So we're looking for those x's. Now, give it a shot. Here's an example. Try to find the linear pairs and all the vertical angles, right? So we'll make a list of linear pairs here. And then vertical angles. Stop the video, see if you can come up with them, and then start it back up and see how you did. Okay, what linear pairs did you find? Did you realize that angle 1 and angle 4 were a linear pair? Because, again, they're side by side, and they form this straight line, right? How about angle 4 and angle 5? Again, side by side, and forming that straight line, okay? And that's really it. I had some talk about maybe 1 and 3 are, but they're not because there's a big old gap between them, right? They're not side by side. Okay, they are sort of forming this straight line, but they're not side by side. Got to be side by side. Okay? So hopefully that helps. Vertical angles. And again, look to trace out some x's. Well, here's one. And I need the angles that are back to back within that x. And the only ones I can use are 1 and 5. There's an angle 4 that's in this x, but there's 2 angles that are to the back of it. And remember that these are angle pair relationships. And so we just need 2 angles. So angle 1 and angle 5 are your verticals. Okay? And that's it. So hopefully that helps you realize linear pairs, vertical angles, or vertical pairs. Okay? One more example for you. 2 angles form a linear pair. Stop right there. You need to know what a linear pair is. Right? There are 2 angles that are side by side that form a straight angle. Right? Which means that they form a straight line or a straight angle, they have to add to 180. They have to be supplementary. Linear pair automatically means supplementary, and we need to commit that to memory. Okay? So, I know that these guys are going to add to 180. The measure of one angle is 5 times the measure of the other. Okay? We don't know either angle, right? So I'm going to have to let one of these angles be x. And since the other angle is 5 times that angle, it's going to be 5x. So in order to find the measure of each angle, I've got to add these 2 up, set them equal to 180. Then divide by 6, and x is 30. So one angle is going to be 30 degrees. The other angle is going to be 5 times 30, or 150, which makes sense. 30 plus 150 does equal 180. So we're in good shape. Okay? All right. That should be it. Homework is out in Canvas. Download that bad boy in Notability. Get that done by next class. Don't forget, we do have a quiz next time. Okay?